Okay, so what we're going to look at today is lesson number 2, adding and subtracting radicals. So what we did look at yesterday and what we had looked at last year is you can't add the radicands together. For example, the square root of 9 plus the square root of 4, okay, plus, does not equal the square root of 13, okay? But there should be a way, or there might be a way of simplifying my adding process. So what I want you to do right now is take a couple of moments. I want you to type in these 5 statements and check whether or not they're true or false. So if I go the square root of 2 plus 5 square root of 2, is that the same answer as typing in 6 root 2? The ones that are true, circle. The ones that are false, cross out. So pause, and then do. And once you've done this, true, 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 false, false. So if I look at my statements that are true and my statements that are false, what is something that I notice? Well, in my true statements, the radicals are the same, okay? Well, my radicals were the same here, but this was false. What was different in this question? The indexes were different. So check again. Radicals the same, indexes are the same, we're good to go. So a rule for adding and subtracting radicals is, first of all, you need to have the same index and radicand. Remember, the radicand is that part that's underneath the radical symbol. And then if they have the same index and the radicand, we can add or subtract the, I'm going to call them coefficients. Coefficients being that number outside the radical. And if there's no number outside, we put the number 1. So if I simplify these 3 statements, 8 root 7 minus 3 root 7 plus 15 root 7. They're all root 7s, they're all same index, so I can look at the coefficients. 8 minus 3 is 5, 5 plus 15 is 20. If I look at question 2, same radicand, same index. So now I can look at my coefficients because my answer is going to be something 5th root of 10. 18 plus 12 is 30 minus 7, and I get 23. And it still works if my radicand is a variable. Root x and root x. Still going to give me a root x in the end. 5 minus 4 is 1. Don't need to put the 1 in front. It just stays as root x. So now what I want you to do, again, you're going to pause. I want you to do these 2 statements and tell me if these 2 statements are true or false. What do you notice? They are both true, which contradicts the rule that we wrote the first time, because the rule that we wrote the first time said that you can't add them when they have like radicals. So does it appear to contradict the rule? Yeah, kind of. But it doesn't. Because what did we do yesterday? We wrote mixed radicals. So let's look at the square root of 8. Square root of 8, according to my perfect squares list, has a factor of 4. The square root of 4 is 2. So now I have root 2 plus 2 root 2. My indexes and my radicals are now the same, which is going to give me something root 2. Coefficient of 1 plus 2 is 3. There's my answer. If we look at 12 and 48 and do the same process, in 5, root 12 I can divide by 4. 4 times 3. Square root of 4 is 2. I get 5 times 2 root 3, which is 10 root 3. And then with 48, I know I can divide 48 by 4. But remember what I said yesterday, if I can divide it by 4, go higher. Try to divide it by 16. Can I divide 48 by 16? I can. I get 16 times 3, which is 4. So now I have 24 root 3. And when I add 10 root 3 and 24 root 3s, I get 34 root 3. So we can modify our rule. In order to add and subtract radicals, they have to be like radicals. So it's kind of like our like terms that we did when we were talking about polynomials. I can add x's to x's, I can add x squareds to x squareds, but I can't add x's and y's. So I can add root 3's to root 3's, but I can't add root 3's to root 6's. I can't add root 5's to cubed root 5's. So they have to have the same radicand and the same index. So in class example number 1, what I want you to do is I want you to pause and then try to do question number 1 and then press play. And I'll give you some time after each question. So pause and let's try to do A. So if I look at 80, I can divide 80 by 16. And then I can divide 20 by 4. So now I've got 4 root 5 minus 2 root 5. Square root of 16, square root of 4. 4 minus 2 is 2. And I get 2 root 5 as an answer. Try B. When I look at B, I have to remember we're dealing with cubed roots. So I have to look at perfect cube numbers. That's the row in green. 80 becomes 8 times 10. And 270 becomes 27 times 10. So then I get 2 times the cube root of 10 plus 3 times the cube root of 10, which gives me 5 times the cube root of 10. Try C. Can be written as 9 times 3, 75, 25 times 3. And chances are 47, try to see if I can divide it by 3. Divide it by 3 and I get 49. So this becomes 7 times 3 root 3 minus 3 times 5 root 3 plus 2 times 7 root 3, 21 root 3 minus 15 root 3 plus 14 root 3. So 21 minus 15 is 6 plus 14 is 20 root 3. Okay, we're going to do the same thing with class example number 2. Try it on your own, then press play and watch me work through it. So 108. I can divide 108 by 36. 36 times 3. 8 I can divide by 4. Uh, 48 I can divide by 16. And 50 I can divide by 25. So I get negative 5 times 6 root 3 plus 3 quarters times 2 root 2 minus 5 quarters times 4 root 3 plus 1/2 times 5 root 2. So I get negative 30 root 3. I'm going to actually move this and start collecting my like radicals. So 5 quarters times 4 is 5. So I get negative 5 root 3 plus 3 quarters times 2 gives me 3/2. And then 1/2 times 5 gives me 5/2. So negative 30 root 3 minus 5 root 3 gives me negative 35 root 3. And 3/2 plus 5/2 is 8/2, which gives me 4. And I get a positive 4 root 2, which I'm going to put out in front. Okay, try to do B. Remember, B is cubed roots. So when we look at B, 64 I can divide, 64 is a perfect cube. The cube root of 64 is 4. So this will become 4/8. Then we have 2 times the cube root of 125 times 3 minus 2 times the cube root of 54, which is 227 times 3. And then the cube root of 24 I can write as 8 times 3. So 4/8 becomes 1/2. Cube root of 125 is 5, so I get 2 times 5 cube root 3 minus 2 times 3 times the cube root of 2 over 3 minus 5 times 3 times the cube root of 3 over 2. So it is a little bit messier because I've got these fractions to deal with. So we've got 1/2 plus 10 times the cube root of 3. But this one right here, we've got 2 times 3, which is 6. 6 divided by 3 is 2. So minus 2 times the cube root of 2. And with this one, I've got 5 times 3, which is 15. Oh, not 5, sorry. This isn't 3, this is 2. 2 times the cube root of 3. There we go. Cube root of 8 is 2, not 3. So I've got 5 times 2, which is 10. 10 divided by 2 is 5. So I've got 5 cube root of 3. The last thing that I would do is check to see if I could combine any of my like radicals. I can combine these two. So now I have 1/2 minus 2 times the cubed root of 2. And then 10 minus 5 would be plus 5 cubed root of 3. So the last part of this lesson will be the last class example, which has to do with perimeter. Finding the length of x as an exact value and as a decimal to the nearest tenth. So if I look at trying to find the value of x, well, the value of x would be the difference between these two radicals. So x would equal 8 root 2 plus 2 root 12 minus 5 root 27 minus 4 root 18. So in order to do this as an exact value, I need to make sure that my radicals are all simplified so that I can collect like radicals. So 12, and this is another way that I shortcut this, 12 I can write as 4 times 3, so I just put it up there. Square root of 4 is 2. 2 times 2 is 4 root 3. 27, 9 times 3. Square root of 9 is 3. 3 times 5 is 15. And then the last one, 18 is 9 times 2. Square root of 9 is 3. 3 times 4 is 12. So now I get to this step. If I was to remove my brackets, think of this as being a -1 multiplied by everything inside the brackets. So I get a -15 root 3 and a positive 12 root 2. Collect my like terms. 8 plus 12 is 20. And then 4 minus 15 is -11. This would be my exact value. This would be A. And then B would be what the calculator gives me when I type in 20 root 2 minus 11 root 3, which is an answer of 9.2. So the questions that I have for you, I will write them down. They were for both parts. Question 2, BCF, 3BE and 5A, 6B, and then 7, and then 9 through 13. Just a quick note before you start. A lot of times in the questions, if you can figure out something like the square root of 20 was 4 times 5, chances are if this index here, or if this simplifies to a 5, this one's going to simplify to a 5, and then I can divide 80 by 5 and I can get my 16. Or even with this 147. These had 3's in them, so chances are this is going to have a 3 in them. So you can use that as your pattern. So just go back to the questions. That's what you have to get done, and we will see you tomorrow in class.